This is Daniel Crawley, Foothills Action Network. Hope you're having a great day wherever you may be. We are getting ready to conclude our Weather School series with Unit 5 on fronts and pressure patterns. And this is something that I know a lot of y'all may be interested in. And these may be some questions that you'll see coming up later in the year when you take your end of year test. So we'll get into this. Fronts. Basically, the first thing that we're looking at here is a cold front. We talk a lot about cold fronts and weather uh, here in the eastern U.S. A cold front is the leading portion of a cold air mass moving against and eventually pushing area of warmer air and pushing it out of the area. You see it a lot from west to east. Colder air will rush into the area. That is a cold front that usually causes that. So, what kind of weather is usually associated with a cold front? Several kinds. Number one, warm and humid out ahead of it. Two, rain, thunderstorms, an active weather pattern, an unstable atmosphere, and potentially windy weather. Here's a look of a radar image of a line of thunderstorms that's moving across the middle part of the country. That is along a cold front. So that is the kind of weather you usually see during a cold front. Warm and humid, stormy, unstable. So what kind of weather occurs after a cold front? A lot of things usually happen after a cold front. Number one, the sky is clear because the storms move out. Generally, your cold fronts bring in cooler weather and lowering humidity. Now, look here. We got windy for after cold fronts. You can have wind both ahead and behind cold fronts. So that is the one thing that can remain constant even before or after a cold front passage is windy. Now, a lot of times here in western North Carolina, we deal with wildfires, and wildfire risk tends to go up while in drought and after cold fronts because you have the wind and the lower humidity. Warm fronts. Now, warm front is a front in which an advancing air mass of warm air tries to rise over cold air. Now, remember in the last unit we talked about how cold air was dense and how it holds to the ground. Well, warm air tries to ride over it. Here's a good diagram of that. You'll have a wedge of cold air, and here in western North Carolina we have what we call cold air wedge events, where you have dense cold air just to the east of the Appalachians, and then warm air is trying to ride over it. That's essentially how a warm front mechanism works. It's warm air trying to rise and go over the cold, dense air. So, what kind of weather occurs after a cold front passage? Normally, warmer air, more humid. The winds will usually shift to the south. You may have a decrease in cloudiness. And then when you get into the summertime, it may increase your chances of thunderstorms. Stationary fronts is basically that transition zone that's between the two air masses, but neither one can really push the other out. So basically your front becomes stationary, becomes stagnant. You see that a lot in the summertime when the jet stream is further to the north, and we'll talk about jet streams in a few minutes. But stationary fronts is basically when one air mass can't win out over the other. Pressure. We basically have two pressure types. First off, high pressure. High pressure always spins clockwise in the northern hemisphere. Okay? Now, high pressure, and this is one thing that you need to remember, high pressure is associated with nice weather. So, high, throw your hand up there, high pressure. Nice weather. Now, you get into the southern hemisphere, the wind flow is different and high pressure is counterclockwise. But here in the northern hemisphere, it's always clockwise. So high pressure is sinking air, calm weather. Low pressure is the opposite. Low pressure is counterclockwise in the northern hemisphere, and low pressure is usually associated with stormy weather. It's a lifting mechanism. It can cause rain, snow, or whatever. Wind. Varying types of weather phenomena. But low pressure is usually stormy weather. L, low as in lousy. That's a good way to think about it. Now, to get clouds to form, you got to have lift. That's something we talked about earlier. And low pressure provides a lifting mechanism. So, as I said just a second ago, when you can lift the air, it becomes stormy, it can rain. You generally see that with low pressure. But when high pressure is overhead, the sinking motion just kills cloud development. There's no way clouds can develop, or at least they're limited, when high pressure sinks. Okay? So high pressure is nice weather, low pressure is lousy weather. Wind is developed by the pressure difference between high and low pressure, and the wind from high pressure will always blow toward low pressure. So if you look at a weather map and you see low pressure that's located here, the winds are blowing into low pressure. Whereas if high pressure is here, the winds are blowing out, away from high pressure. So the next thing, what is the jet stream? The jet stream is a fast-flowing river of air, usually around 10, 15,000 feet in the air. They form at the boundaries of different air masses, where it's warm and where it's colder. So kind of that boundary area is your jet stream. The jet stream is also a mechanism to help steer weather patterns in whatever direction. So looking at this map right here, we talked about high pressure and it being dry and it being sinking air. And we talked about low pressure creating lift. Well, basically, your battle zone in between is pretty much where your jet stream is going to lie. Here's an example of a weather map showing areas of low pressure and high pressure, your cold fronts. Here's an example of a map on low pressure and how you have precipitation usually out along low pressure. Which if you look at this weather map during the winter, if you're in North Carolina, that gets you a little excited because you got cold air coming in and you got low pressure bringing the moisture. And if you can combine the cold air and the moisture, who knows, it might snow. So the last two things we're going to talk about, and these are very popular weather and climate topics. El Nino. El Nino is the temporary change of climate around the Pacific Ocean. It's the area close to the equator, as you can see in what I'm showing you. It's the change in the water temperature. When the water is generally warmer in this part of the world, you're under an El Nino. Now, El Nino is warmer than average water. And it can have an influence on the weather here in the United States. Normally, during an El Nino, you get wet weather. We've had El Ninos in the past that have been really wet in the United States. The opposite is a La Nina. What we have, looking at this map, you can see generally colder than normal water temperatures near the equator and the Pacific. So what happens is the colder air is the La Nina, or the colder water temperature, excuse me. And the way that impacts the weather here in the United States is generally mild and it's generally less wet. You can run into some dry spells during La Nina. So remember, El Nino is the warming of the water in the equatorial Pacific near the equator, and La Nina is the cooling of waters in the equatorial Pacific. You may see those questions at some point. Okay, that is the end of our Weather School series. Once again, I'd like to thank everyone for watching. And we've talked about the last 5 units about different weather things. Again, if you have any questions about Weather School, any topics that we may have that maybe we haven't covered, as always, you can check us out on our Facebook page, leave us a message, or you can email me, or you can email our Chief Meteorologist, Chris White. Again, thank you for allowing us to come in and being a part of your educational experience. And hopefully this will be something that you guys will take and be able to use when you head into your studies later in the school year.